In this video, we are going to use our knowledge of parallel and perpendicular lines to identify if a pair of lines are parallel and perpendicular, and then we're going to graph parallel and perpendicular lines. In question 1, we are to determine if the following pairs of lines are parallel, perpendicular, or neither. Before we answer the question, let's look at the notation used for parallel and perpendicular lines. For parallel, we draw two lines with little arrows. And for perpendicular, you draw a pair of perpendicular lines and then you draw the little right angle symbol. So in question A, we are given two equations. To identify if these are parallel or perpendicular, we need to look at the slope. So each of these equations are in the form y equals mx plus b, so we can easily identify the slope. And the first equation is just 5 over 2, because that is the coefficient in front of x. And in the second equation, it is 2 over 5, again, because that is the coefficient in front of x. So now we are going to compare the two slopes. They are not the same, so that means these two lines are not parallel. They are reciprocals, because 5 over 2, the reciprocal of 5 over 2 is 2 over 5. However, they are not negative reciprocals. So this second slope would need to be negative as the first slope is positive. So even though they're reciprocals, they're not opposite signs, therefore they are not perpendicular. So we would therefore say these pair of lines are neither parallel or perpendicular. Looking at the second pair of equations, again, they're both in the form y equals mx plus b. We're going to identify the slope. So look at the coefficient in front of x. Here, as it's just written as x, we know the coefficient is 1. So we would say that the slope is 1. I like to think of slope as rise over run, so I'm going to write this as a fraction, 1 over 1. And in the second equation, we have negative x, so that's actually negative 1x. So here, when I identify the slope, m equals negative 1. Again, I want to think of the rise over run, so that's negative 1 over 1. So now let's compare the two slopes. They are not the same. One is positive 1, the other is negative 1. So these are not parallel lines. But these lines are, in fact, perpendicular, as these slopes are negative reciprocals. It is a little harder to see when the coefficient is 1 to identify that these are negative reciprocals, but they are. So look at the first slope, 1 over 1. Take the reciprocal. Again, you get 1 over 1. The first slope's positive, and the second slope is negative. So therefore, these two lines are perpendicular as the slopes are negative reciprocals. Looking at the third pair of lines, the first line is written in the form y equals mx plus b. The second line is not. So the first thing we need to do is rearrange the second equation so it has the form y equals mx plus b. So I'm going to subtract 3x from both sides to get 5y equals negative 3x plus 10, and then divide all terms by 5. So we get the equation y equals negative 3 over 5x plus 2. So now that both equations are in the form y equals mx plus b, we can identify the slopes. The first equation has a slope of negative 3 over 5. And the second equation, we're going to look at the rearranged form. We see negative 3 over 5 as well. So comparing the slopes, they are the exact same. Therefore, these pair of lines are parallel. Looking at the last set of equations, both are in the form y equals mx plus b. The first equation has a decimal, so I'm going to write that as a fraction. So the first equation, 0.5, is just 1/2 as a fraction, minus 4. The second equation is fine. So now let's identify the slope from the first equation. It's 1/2. So m equals 1/2. And then the slope from the second equation is also 1/2. So just comparing these two slopes, they are the same, even though one was written as a decimal, the other is written as a fraction. It is better to write slope as a fraction. So we can now see that the two lines are parallel. Note that in all of these examples, I did not look at the y-intercept, only the slope. So in the second question, we are asked to determine the slope of this line segment AB given the points A and B. We are asked to do that without graphing. So that means we want to use the slope formula. So to do that, I'm going to write the 2 points, one above the other, identify the x-coordinate and the y-coordinate, and then write down the slope formula. Rise, so y2 minus y1, over run, x2 minus x1. So I'm going to take my second y, 6, and I'm going to subtract my first y. So 6 take away -2, and then in the denominator, so take your first x and take your second x, the one at the bottom, and subtract your first x. So -4 take away 3. 6 take away 2 means I'm adding 2. So my numerator is 8 and my denominator is -7. And then in part B, we are asked to state a parallel slope and a perpendicular slope. So a parallel slope, so I'm going to identify that because we're asked for two different slopes. So I'm going to use that notation for parallel. So M for slope, and then these two little lines with those little arrows to represent parallel. So a parallel slope is just going to be the same. So -8/7. Here I just wrote the negative in the numerator. It doesn't matter, again, where you write your negative for a fraction. It could be in the numerator, the denominator, or right in front. But we have the same numerator, the same denominator, and overall we have one negative. So these two slopes are parallel. For perpendicular, I'm going to write M with the perpendicular symbol, so the perpendicular slope, and I'm going to take the negative reciprocal. So this first is the negative, and then when I take the reciprocal, I'm going to flip the fraction to get -7/8. When you have a negative of a negative, two negatives make a positive, so this is simply +7/8, and you don't need that positive symbol. You can just write 7/8. So the perpendicular slope is the reciprocal with the opposite sign. So our original slope was negative, so our perpendicular slope is going to be positive. In question 3, we're asked to graph a line, y equals 2x minus 5, and then we're asked to graph a parallel line that passes through a specific point. So to graph this line, I just make sure it's in the form y equals mx plus b, which it is. I'm going to identify the slope, which is 2. And I'm going to write that as 2/1 to think of rise over run. And then the y-intercept is -5, which has the coordinates 0, -5. So I'm going to begin at my y-intercept, and then I'm going to rise 2 and run 1. So on my graph, I'm going to start below the origin, and then I'm going to rise 2, run 1, and plot a point there. And again, from that new point, I'm going to rise 2, run 1. And from the new point, rise 2, run 1. And I will go a couple more points. And then with your ruler, draw a line through all of your points. Extend it throughout the grid. Draw arrows at the end, and then label your equation. Y equals 2x minus 5. In part B, we want to graph a parallel line that passes through the point -2, 1. So because the second line is parallel, I'm going to take the slope of the first line. So the parallel slope is also 2 over 1. And this time I'm going to pass through the point -2, 1. So I don't have the y-intercept. I don't have the equation of the second line, but I have enough information to graph it. I have a point that it passes through, and then I have the slope because I know this line is parallel to the above line. So I'm going to graph this in a different color. So I'm going to pass through -2, 1. And then again, from this point, I'm going to go up 2 over 1, plot a point, and again, up 2 over 1, and keep going. So I want to draw some points to the left of my original point. So I'm going to now go down to left 1. So double negative, which makes it positive. Down to left 1, down to left 1. And then extend a line through all those points. I don't have the equation of this line, so I'm not going to label it. But in the end, you can see we have two parallel lines. They are never going to meet. They both have a slope of 2, but they have different y-intercepts. The first equation has that y-intercept of -5, and the second equation we can actually see 1, 2, 3, 4, 5. It has a y-intercept of +5. Question 4 is the same idea as question 3, where we are asked to graph a line. And then we are asked to graph a line that's perpendicular to the first line, given a point. So the first equation we are given, I need to rearrange because it is not in slope-intercept form. So I'm going to take away x from both sides to get -3y minus 12 equals -x. And then I'm going to add the 12 to both sides to get -3y equals -x plus 12. And then I need to divide by that coefficient in front of y, which is -3. So anytime we divide by a negative, let's be careful with our signs. -x divided by -3, so that's -1x divided by -3. Two negatives make this positive. So I am going to write this as 1/3 x. We're used to writing the fraction in front of the coefficient. Note you could write this as x over 3. That is fine. You might have a tougher time identifying the slope, but you can see the slope from x over 3 because that's 1x divided by 3, so it's 1/3 is your slope. And then your second term is +12 divided by -3. Positive divided by negative is negative. 12 divided by 3 is 4. So that is the equation of your first line that you're asked to graph. So here we can see that the slope is 1/3 and the b value is -4. So we're going to begin at -4, and then we're going to rise 1, run 3, rise 1, run 3. We could also rise -1 and run -3. And then we'll draw a line through those points, label it because we have the equation. You can label with the original equation or the rearranged form. In part B, we now need to graph a perpendicular line that passes through the point -2, 4. Because we want the perpendicular line, we need to take the slope of the original line and take the negative reciprocal. So the perpendicular slope is going to be -3 over 1. So we flip the fraction to get 3 over 1, and we make it the opposite sign. So the original slope is positive, so the new line is going to have a negative slope. So it's -3 over 1, and we're going to plot it through the point -2, 4. So start off at the point -2, 4, And this time we're going to go down 3 to the right 1, down 3 to the right 1. And I should do this in a different color. So there we have the new line. You can see that they meet at a 90-degree angle. We can see that the first line has a positive slope, the second line has a negative slope. And finally, in number 5, we are given a special case of a line, x equals -2. So you should identify this as a vertical line because it crosses the x-axis. To cross the x-axis, it needs to go up and down. So it's a vertical line. A vertical line has an undefined slope. And it crosses the x-axis at -2. So I'm going to identify where -2 is. So it's here. And then I'm going to draw a line through that point. And the equation of that line is x equals -2. So any vertical line is going to have the form x equals wherever it crosses on the x-axis. In part B, we're asked to graph a perpendicular line that passes through the point -1, -5. So the perpendicular line, to be perpendicular to a vertical line, it must be a horizontal line. So this we know must be horizontal, going this way, and any horizontal line has a slope that is 0. So a horizontal line, and it tells us that it crosses at the point -1, -5, which is here. That's your point. -1, -5 is right here. And to be perpendicular, we're going to draw that horizontal line. And the question doesn't ask us to, but we can find the equation of this line. It crosses the y-axis at 1, 2, 3, 4, 5 below the origin. So that has the equation y equals -5.